Okay, so we are starting our unit today on congruent triangles. But before we start any new stuff, we're going to kind of look at some stuff that you guys probably already know. So bear with me while we kind of fly through this. First thing we're going to talk about is how to classify angles. First, we're going to talk about how to classify them by their, sorry, I meant classify triangles. We're going to look at how to classify them by their angles and how to classify them by their sides. So, first one that we're going to look at is by angles. If I have three acute angles in a triangle, I am just calling that an acute triangle. Next, if I have one obtuse angle in a triangle, I'm calling it an obtuse triangle. If I have a right angle, I'm calling it a right triangle. All of those should be relatively familiar to you. The only one that you might not actually know the word for is this last one. If I have three congruent angles, you probably recognize it as being an equilateral triangle. But if I'm talking about its angles specifically, I am saying that it is equiangular. An equiangular triangle. So, very similar to equilateral in what it actually means, but I'm actually talking about its angle. So that's kind of where that difference lies. So down here, it's saying use the diagram, classify each triangle by its angle. So the first one says, look at triangle CDE. So CDE is this guy right here. Notice, I've got one right angle down there. So the way that I'm classifying it by its angles is as a right triangle. Not too hard, right? So now let's look at the next one. It says BCE. So let me erase this so there's not too much crap going on here. BCE. Notice you kind of have to work your way around to figure out what kinds of angles you have inside that triangle so you know how to name them. Right here, I've got two acute, but then right here, that one looks like it's an obtuse. And remember, if I'm looking up here at my definitions, if I'm classifying by angles, one obtuse angle means I've got an obtuse triangle. So that, I'm not going to do too many of those because I think you'll be okay with that. Only one that I kind of want to address is this guy right here. Sorry, the smartboard is crazy, but triangle ABE. Again, these little things in there, those tell me that all those angles are congruent to one another. And if I'm classifying by angles, the way that I'm saying that is that they are equiangular. Okay, so let's move on. Let's move down here. We're going to start talking about how am I going to classify triangles by their sides. So, three different ways that we can do it. Also words that you probably are familiar with. The first one I've already mentioned, three congruent sides. That is an equilateral triangle. Two congruent sides is an isosceles, and no congruent sides is a scalene. So some of those might have been ones that you could have filled in on your own without me actually doing anything for you. So if I'm doing the same thing that we did up top with 6, 7, and 8, I'm using this diagram, but this time I don't care about the angles, I care about its sides. So the first one asks me classify JKM. JKM is the whole thing. Notice I don't have any markings on these three sides to indicate that like this side is equal to any of the other ones, or this side is equal to any of the other ones, so on and so forth. So since I've got three sides that are not congruent to any of the other sides, I'm calling this guy a scalene triangle. Again, I'm not going to spend too much time on those because I think you guys are okay with that. So let's skip 9 through 14 for a minute, and let's go on over to, let's take a look at some of these. Because this uses some of the words that we have looked at from our previous units. So the directions say if PR bisects SRT, so remember, bisects means cuts in half. So PR bisects SRT, so here's PR. And it's saying it's bisecting angle SRT. So what that gives me then, if you recall what bisecting an angle means, they told me that this little piece over here is 30. Since it's bisected, it means that's 30 as well. So I've got two 30-degree angles there. And the second piece it gives me is U is the midpoint of RT. So let's see, RT is kind of covered up, but RT is this guy right here. And that's U. Remember, midpoint cuts the side in half, cuts the line segment in half. So if this right here is 8, then that means this right here is 8. And if that's 8, if you notice in here, it also told me that these two sides, remember these little tick marks mean congruent. If this is 8, then this is 8 as well. And that's going to help me figure out some stuff about these triangles. So I'm not actually going to do any of these for you because I think that you'll be okay just kind of looking at using what you know about triangles, about scalene, isosceles, equilateral, and the other 4 words we looked at. But what they want you to do here, you need to classify it by angles and sides. So what that looks like let's look at TQU, number 19. What that looks like when I'm classifying by angles and sides is I'm saying, okay, let me look at all the angles. All of the angles in here, let me erase some of this stuff. In order to do this, you need to remember kind of some of the other stuff that we know about lines, about triangles, that sort of stuff. One thing that I know about this angle is that it's supplementary with this one next to it. It's supplementary with that 120. So what that means is, if that's 120, that's 60. Hopefully we know, and if not, we'll get a lot more practice with it very shortly. There's 180 degrees in a triangle. So if I've got 180 degrees in a triangle, and two angles of it are 60, then this one is also 60. So triangle TQU, I know, we said before, I'll put it back up there, that this is 8 and this is 8. So I know all of those sides are 8. So if I'm classifying by sides, I'm saying it's equilateral. If I'm classifying by angles, I'm saying it's equiangular. So that's what each of those responses should look like. Those should each say one answer for how I classify it by angles, one answer for how I classify it by sides. Okay. Moving on, down here, this is going to give us a little bit more practice with our distance formula, because I know we used that a little bit last unit, but we want to make sure that we don't forget it. It's saying classifying triangles in the coordinate plane. In the coordinate plane means that I'm looking at this thing on a graph, on a set of axes. So it says find the measures of sides JKL, then classify it by its sides. So what that means is just kind of estimate where these points are going to be if I put it on a graph. So all of these should have kind of a little graph next to it. So if I have JKL, they said J is -7, -7. So J is going to be somewhere down here. K is -9, +1. So that's going to be kind of up there. And L is going to be -1, -1. So right about there. Oops. I'm too close to the edge. Okay, so that's my triangle. All I'm doing though here, you know how to do this. This is asking me find the measures of the sides. The measures of the sides in the coordinate plane is just talking about the distance of it. So I'm going to say the distance of, and I'll actually kind of notate the difference for it. The distance of, we'll do JK first, equals, remember, distance is subtract my x's and square it, plus subtract my y's and square it. Add those two together and then throw it under a radical, and that's it. So then you're going to go through and do that math out. Remember, this turns into addition. So that will be 16 squared plus, this is going to be -7 minus 1, -8 squared. And then you're going to do that math out. The only thing I want to point out, I don't know what 16 squared is, I don't care right now. Something that a lot of you are doing is when you are squaring a negative number, remember, squaring something means you're taking that thing and multiplying it by itself. So I'm saying -8 times -8. When I do that, your answer should be positive. If you are squaring something, you will never, ever, ever have a negative number in your answer. It will always be positive. So what you're doing here, you're finding the three distances, and then you're just comparing each of them. If I have three distances that are 1, 2, and 3, you know that those are all different. So I'm going to say, well, I know that's a scalene triangle. So that's all we're doing here. And I'm not going to have you do all of those. You only have to do a couple of them. But let's turn the page, because I want to do two more quick things. I apologize. I know this is a lot of different information, but you'll live. So, and again, this is kind of stuff that you already know. We're talking about here isosceles and equilateral triangles. So the first thing we've got here is talking about isosceles. So parts of an isosceles triangle. The two congruent sides are called the legs. So I'm going to actually label right here. This guy right here is a leg, and that right there is a leg. The angle where the legs intersect is called the vertex angle. So in this case, angle 1 is my vertex. The side opposite the vertex angle is called the base. So something that we want to get comfortable with is talking about sides opposite angles and angles opposite sides, because throughout this course we're going to do a lot of stuff where that becomes very important and helps us solve problems. So right here they're saying the side opposite the vertex is called the base. So if I'm going opposite an angle, I'm going to where I have to go right through that triangle to get to the other side. So if I'm starting at that vertex angle to get to the base, my base is going to be down here at AC. And then the last thing on there says the angles along the base are called the base angles. So angles 2 and 3 are my base angles. Sorry, this is getting a little messy, a little crazy, but it'll be okay. So here's a little theorem that they've got for us, and I think it's something that you already know. It's telling me that if two sides of a triangle are congruent, aka it's an isosceles triangle, then the angles opposite those sides are congruent as well. Again, we want to get comfortable talking about what we know about angles opposite sides or sides opposite angles, whatever. So if I'm doing that, if I'm looking at this theorem, the two sides of a triangle are congruent. The angles opposite those are congruent as well. These are my two sides that are congruent. If I'm going opposite them, this angle is opposite AB. So angle 3 is opposite side AB. And angle 2 is opposite BC. So those two angles that are congruent there, which we know from this stuff up here already, are angles 2 and 3. So I'm going to kind of put here, if AB is congruent to BC, then angle 2 is congruent to angle 3. The next thing is saying the exact same, it's pretty much the exact same thing. And we'll talk about what this word converse means in the next unit. But converse basically just means we're taking this thing up here and we're flipping it backwards, but we're saying the outcome is the same. They're saying, okay, instead of having two sides congruent, we're telling you two angles are congruent. And if that's the case, the sides opposite those angles are congruent. So I'm going backwards. I'll say if angle 2 is congruent to angle 3, then AB is congruent to BC. Again, these are not all that different. And I'm not going to make you memorize what each of those mean. All I care about is that you know that those two base angles of an isosceles triangle are equal to each other, and the sides across from them are equal to each other as well. So the way that we're going to use that, I'm going to kind of skip. Well, actually, let's take a look at number 2, because this is kind of applying that idea of the isosceles triangle theorem, saying that my two base angles are equal if I have sides that are equal. So right here in number 2, they're telling me that this angle right there is 106. Now remember, 106, that angle is this guy. That's my vertex. My vertex angle isn't equal to anything in an isosceles triangle, but I have these two sides that are equal to each other, and if I go across each of them, isosceles triangle theorem says that those two are congruent to each other. What that means for me in trying to find what angle C and what angle E are is that I can say, well, I know there's 180 degrees in a triangle. That's something that we know. I know that 106 of those degrees are taken up by that vertex angle. And the third thing I know is I know that C and E are equal to each other. Well, if I have 74 degrees left in this triangle to go between two angles equally, I'm just taking that number and dividing it by 2, making each of those 37. And that's kind of what a lot of these problems turn into, figuring out what you know about the angles that you're given, what you know about other angles besides the one you're given, to actually figure out different things about each of these triangles. So let's take a look at like number 5, for example. As you will learn, as you hopefully have been learning, a lot of the problems that we do, the way we set them up is completely based on what I know about the angles, about some of these are going to be the sides. That's going to lead me to my setup. So let me erase some of this stuff so it gets out of our way. Right here in number 5, they told me that these two sides are equal. That's cool, so that makes it an isosceles triangle. You want to look at what else they labeled in there. If you look up top, you'll notice that these two angles that they're labeling for us are the base angles. Those are my two base angles. This is my vertex, and these are my base angles. Well, we know that the base angles of an isosceles triangle are congruent Remember, congruent means equal. So when I set this problem up, I'm just saying, okay, well, I know this angle is 4x plus 7. I know this angle is 9x plus 33, but I also know that they are the same thing. So they're equal to each other. And then I'm just going to solve that problem like I normally do. I'm going to add 33 to both sides, so I'll get 40. And I'm going to subtract 4x from both sides, so I'll get 5x. Divide out my 5. X would equal 8. So again, a lot of this is just based on what I know about each of these, about all of the angles inside these triangles. That's what's going to help me here. Okay, so last thing, like I said, I apologize, I know it's a lot of notes, but I think it's pretty familiar stuff, or at least should be. Flip to page 4 in this packet. So on page 4 and towards the bottom, it's got some stuff about equilateral triangles. So it's saying a triangle is equilateral if and only if it is equiangular. So that's that word equiangular again popping up. And all that means is pretty much what we already know. If a triangle is equilateral, we said that we already know that all of its angles are equal. So that's not really any new information there. So it says there, if the measure of A equals the measure of B equals the measure of C, those are all equal, then triangle ABC is equiangular. I think I spelled that wrong. Angular. And the last thing there, if AB is congruent to BC is congruent to AC, so if this is equal to this is equal to this, then I'm just talking about I'm classifying it by its sides. Then ABC is equilateral. Nothing too exciting there. So let's actually go down, number 11 and 12, those aren't very exciting because all of those answers are going to be pretty much the same. But what is a little bit trickier is like if I look at number 13, they're telling me that PQR is an equilateral triangle. They want me to find X and Y. My X's, my expression with an X in it is pointing to an angle, and I've got Y's on all the sides. Now, the X one isn't too bad, because we just said that we know that all of the angles in an equilateral triangle are equal. And if they're all equal, then they all have to equal 60. So I know, they're telling me this is 7x minus 3. I also know it's 60. Those represent the exact same angle. So I'm going to say 7x minus 3 equals 60. And that'll give me my x. I can solve that, and I can say 7x equals 63. And x equals 9. The tricky part about the sides and finding out what y is because they gave you more information than you actually need. So they told me, again, this is an equilateral triangle, so I know that all of these are equal to each other. I don't need all of those sides together. All I need are two of them. I need to be able to say, okay, well, one side is 11y minus 23, and I know another side is 9y plus 1. So again, I'm just solving that, and I'm going to say 2y equals 24, and then y equals 12. So nothing really too exciting there. That's it for today with these. I'm sorry again that it's like 25 minutes, but hopefully a lot of that is kind of review-ish. I'm going to leave some different problems for you to practice with that will kind of give you the hang of this stuff, and we'll talk about it again when I am back.